Reactive extensions is what I'm going to talk about. A few months ago I started looking into reactive extensions just as a pet project to understand it, something sounded interesting. Since then I've been finding reactive extensions in pretty much everything, so we're finding it in all different frameworks. I've been finding it as a solution to every single problem I come across, as you tend to. Of course it's not the solution to every problem, but there are some really good use cases for reactive extensions. Reactive extensions provide you a way to create streams of events, to manipulate those stream of events, and to subscribe to receive those stream of events and do something with them. Woohoo! Alright. Reactive extensions. Almost every modern language has an implementation for them, as well as frameworks. Tonight we're going to look at the JavaScript version RxJS, which is getting pretty popular in the Angular 2 or Angular 4 community. But it's really, you'll find it everywhere through .NET as well. So recently my team have been working on a Xamarin app. And in Xamarin we've got Reactive UI, which is a MVVM framework based on reactive extensions. You've got reactive properties, which are a way to create a property that you can subscribe to and you can manipulate like a reactive stream. And we're using Redux.NET, which also exposes its store as a reactive extension, through reactive extensions, so you can subscribe to its store and receive those changes. And that's just a small community in Xamarin. Reactive extensions are finding their way everywhere. So what do reactive extensions look like? They're going to be really familiar. The syntax is going to be, for anyone that's done any sort of link in C# or any sort of array manipulators in JavaScript, you're going to see they look just the same. The top is just a standard ES6 syntax where we've got a for each loop iterating through some sort of iterator array. And a reactive extension statement looks pretty much the same, except instead of for eaching it, we're subscribing. So while the syntax is really similar, the underneath is fundamentally a lot different going on. The big difference is that a normal array accessor, like a for each loop, is a pull system, whereas reactive extensions is a push system. Explain it best by looking sort of at this table. Reactive extensions, they call a reactive extension stream an observable. So the observable sort of fits in this missing piece in the puzzle. If you imagine that a single function of code is a pull system that returns a single value. Whenever you want that value, you call the function, it does some processing and returns you the value. An iterator or an array is a pull system that returns multiple values, so whenever you want a value from it, you call next on it, you get your value, you process it, then you call next to get another one. A promise is an example of a push system that returns a single value. So you'd create a promise, you'd say, when this promise is fulfilled sometime in the future, call me back on my handler, and so I can do something. And reactive extensions, an observable is a push system that returns multiple values. So you subscribe a handler to it, and in the future, when it emits events, your handler will get called for each different time it emits an event. So a reactive extension statement generally has this flow to it. You're going to create an observable. There's a long-winded way of creating an observable through a generator function, but there's lots of extension methods that you'll probably find you'll use. In RxJS, probably one of the most common uses is to manage UI events. So here we're listening to button clicks. We could be mouse moves or anything. We'll manipulate all the events that come out of that stream, that observable, and then we'll subscribe to it to do something with the resulting values. So we can create an observable from an event. RxJS is also framework aware, and that means that it understands jQuery, it understands Angular. You can give it a jQuery object here and give it a jQuery event, and it will bind the jQuery event for you and create and emit events as that jQuery event events are raised. Same with Angular. You can also subscribe, you can create something from an array or any iterable thing. There's new generator functions in ES6 which use a yield syntax, which we'll be familiar with in C#. That's coming new to JavaScript now. You could create a generator function there to create an observable from. You can also create an observable from an interval so that every second you get an event, useful for timing or game development. You can create it from a range of numbers, like your enumerable range. You can say 0 to 9, just give me an event of 1, 2, 3, 4, 5, 6, 7, 8, 9. So once we've created the observable, well, we want to subscribe to it. In reactive extensions talk, when you subscribe to an observable, you subscribe an observer to the observable. And the observer can have a different flavor. It can either have just one function, which is your next handler, which says every time an event gets emitted, process it through this method. You can have an error handler as well if you want, similar to a promise, where any errors get bubbled up to you. And finally, you can subscribe to when the stream is complete. Not all streams will be complete. Some, like interval, will go on forever and ever, emitting an event every second. But a lot of streams will complete, and sometimes you want to do something when it's done. An important difference between an observable and an observer pattern, because this feels a lot like the observer pattern that we're familiar with, where you subscribe to an observer. In an observer pattern, you have a bunch of subscribers subscribing to that observer, and when an event gets published through this observer, every subscriber will generally get that same event. In reactive extensions, every time you subscribe to an observable, you're going to get a new stream created for you. You're going to get a whole new observable. So the generator function for that observable gets called yet again. To illustrate that, a simple little example. We're going to create an observable that basically just creates a random number and returns it and then completes. Every time we subscribe to that observable, we get a new random number. Sometimes you don't want that behavior though. Sometimes you actually want an observable, and you can subscribe lots of times and get the same events out. And you can do that. That's called multicasting. The magic sauce, though, in reactive extensions is operators. So what you can do with that stream and manipulate it. There's pretty standard ones in here, like scan, which is pretty much the same as a reduce function, which says every time an event gets emitted, in this case an event is going to be A or B or C, it goes through an accumulator function and it produces the accumulator result. Scan is slightly different to reduce, where reduce would wait for the entire stream to come through and then accumulate them all together. Scan will emit the accumulated value every time a new event was emitted. There's interesting things you can do with observables when you start combining them together. So in this example, we're going to zip two observables together. It's pretty much what it sounds like. We're going to merge them together. Whenever an event gets emitted from both observables, so once they've finally both emitted at least one event, we'll put that through a function and return the result onto a new stream that has a result of that. Zip waits for both of the observables to emit an event. There's other operators we can use that can say as soon as any one of them emits an event, then just grab the last value from the other one and combine that. There's a bunch of different ones that can be really valuable. And probably the most useful one is merge map, or for those familiar with LINQ, it would be the select menu, where we can take a stream, we can, from the events in that stream, we can call out and create a new observables, but then eventually we want to flatten them all back together so we can process them all together. So for example, in this scenario, this is something I was working on. We would go to a remote server, fetch a list of folders. Then for each of those folders, we go back to the remote server, say get me a list of the files. Rather than then having a nested subscribe after each file we do something, we can fold all those files back together and processing all as a single stream. The value of creating it in a single stream is that you can really reason about it easily. You can see what's going on with it, granted, once you've sort of got familiar with the syntax. Oh, and the last example, this is one we are using in our app already. It's great for search, so you can imagine if someone's typing in a search term, you don't want to be sending off a search request for every single character. You're going to be wasting resources, so you want to wait till they've paused for a second and then execute the search. So debalance time does that. It says as soon as you start receiving events, wait until there's a gap of at least a second and then just emit the last event. There are over 180 other operators in RxJS, so it can get quite overwhelming, but there's one for almost everything you want to do. The complex thing is finding the one that you want to do the thing you want to do. So RxJS reactive extensions have put together this decision tree, and it's actually really useful. In the work I was doing, I'd be referring to this all the time just to come in and go, often it was just to repeat that actually I want the same operator every time, but you just kind of get your head in, I'm trying to do this thing, you read through the syntax, you go, oh, so I still just want the scan operator. It's helpful to make it, to bring you along the journey. Interestingly as well, I think RxJS probably has the best documentation out of any of the implementations. So even if you're building in Rx Python as it was doing, or in Rx.net, often RxJS is the best place to go to read up about what that thing does. They've almost all got the same operators. They're just slightly different implementation. It's pretty easy to translate it in your head. All the concepts are the same. So recommend going over to RxJS documentation even if you're not using that. Cool. And just a couple of, I guess, observations that I had as I was working with it. Firstly, this should be familiar with anyone who's done promises as well in JavaScript, is flatten those subscriptions. So in JavaScript, the whole point of promises was to remove that perimeter doom. But we've often seen in code that promises end up becoming chained as well, and we have this big perimeter doom coming back. Same thing can happen with reactive extensions. You can have an observable that is subscribed to, that creates another observable that's subscribed to, and this can get steadily worse. So we use merge map or that select many just to fold those back into a single stream that we can subscribe once to. This is another one. There's this handy dandy little operator called do in reactive extensions, and it basically it's like for each. It allows you to do whatever you want, any side effects. Problem is that all the other operators in reactive extensions are pure. They take a stream, they provide a mapping function to it, and they emit a whole new stream that map those values. Do doesn't, it does side effects. This can make your code really hard to reason about. So really recommend anytime you feel the need to use do, don't. And put it down in your subscribe method. There's a better way to do it. In this case, maybe you just need to fold it back again or map it. Often you use do because you don't want to lose the context of what you're doing. So you can map it and just put it in an array so you've got the context of things you're working with. Lastly, my last tip would be write your own extensions. They're really simple. This is a full extension for RxJS, and most implementations aren't much longer than this in any language. If you find yourself using the same set of operators over and over again, the same sort of pattern, then just put in your own extension and give it a name. It makes your code so much more descriptive. This is one I was using that just would have a boolean if this is the last event in the queue, because I needed to know that. Yeah. Cool. That's me. I'm Paul. I work for PageUp. If you've got any questions about us or what we do, we're always looking for talent. Come talk to me. Thanks.